Let's quickly mention network boot and install. My 8-year-old daughter's favourite technology. How come my 8-year-old daughter's favourite tech then? Well, booting and installing over the network uses a technology called PXE, an acronym for Pre-Boot Execution Environment. But it's pronounced, at least by most people, as PXE, so kinda like pixie dust or fairy dust. And my daughter loves fairies. Anyway, so it's possible to boot and install RHEL 6 from the network using PXE. And in enterprise environments, installing via PXE is pretty common. In fact, actually, we can configure RHEL as either a PXE client or a PXE server, meaning that RHEL can boot and install from a PXE server, as well as be that PXE server that provides other machines with the ability to boot and install from the network. But for us, we're interested in how the early stages of the PXE boot process works, as it's quite a bit different to booting from disk. After all, right, most networks don't have a master boot record located at cylinder 0, head 0, sector 1. So, first things first, we need to have a server. And that server obviously needs a network card, a NIC. But not just any old NIC, a NIC that supports PXE boot. And that NIC needs to be listed in the BIOS's list of bootable devices. In fact, to be used, it needs to be at the top of the list, or at least above any of the devices that have a valid bootloader. Otherwise, one of those other devices will be picked first by the BIOS, and the BIOS will never get as far as trying the PXE boot. Next, we need a DHCP server, and we also need a TFTP server. So, a NIC with a PXE stack, and a BIOS that supports using a PXE NIC as a boot device. Then, a DHCP server and a TFTP server. And the TFTP server also needs the relevant PXE Linux.0 image file. Then, at a high level, okay, the PXE-capable NIC broadcasts an extended DHCP discover packets on the network, and they get picked up by the DHCP server. The DHCP server then responds with the address of one or more TFTP servers, and the location of the boot files on the TFTP server. Now, we're compressing things a little here, okay, because we're just giving that high-level overview. We'll maybe go into more detail in a future course on installing RHEL, but for now, right, this is enough to give us an understanding. Now, this information from the DHCP server comes back just the same as and along with the standard IP configuration data that hosts normally get from a DHCP server when they power up. Our server over here then goes and contacts the TFTP server and requests the boot image, that PXE Linux.0 network boot program. This is then downloaded into memory and executed, and from then on it's pretty much the same as a standard boot and install process, other than files, config files and other resources are pulled from the network rather than a locally attached disk. And one final word of warning, okay? The PXE server really should live in a trusted area of the network, as the services that it provides aren't secure. Same goes for any DHCP servers, I suppose, as well. They need to be trusted because they hand out the PXE details. And that's us done. Let's go wrap up the module.